Okay, so we want to write a polynomial that has roots x equals -2 and x equals 3i. Since I'm given an imaginary root, I know that automatically the opposite of it is also a root. So if 3i is a root, that means -3i is also a root. So to find what that original equation is, I'm going to put everything back into factor form. So x equals -2 in factor form would be x plus 2. X equals 3i back in factored form. I'm moving the 3i over, so the signs are just going to change. So I have x minus 3i. And then likewise with x equaling to -3i, move it back over, I get x plus 3i. So these are the factors of my original function, and so multiplying them all back together, distributing everything back out, will give me my original function. So I'm going to multiply the ones with the imaginary numbers together first, and then distribute it into x plus 2. It doesn't matter the order, but it sometimes makes things a little simpler that way. So ignore the x plus 2 for a second. Let's distribute this. So x times x gives me x squared. X times 3i gives me positive 3ix. And then distributing the -3i. -3i times x gives me -3ix. And then -3i times positive 3i gives me -9i squared. So I'm still multiplying all of that times x plus 2. Let's do a little cleanup. Notice that my middle terms are going to cancel out. I have a positive and a negative, so those go. And remember, I squared equals what? -1. So -9i squared just gives me +9, right? Just changes that sign because I'm multiplying by -1. So all I'm left with is x plus 2 times x squared plus 9. And now distributing that, x times x squared gives me x cubed. X times 9 gives me 9x. 2 times x squared gives me 2x squared. And 2 times 9 gives me 18. So we can rewrite that. We like our polynomials to go in descending order, highest to lowest power. So we'll end up with f of x equals x cubed plus 2x squared plus 9x plus 18. So we found a polynomial that has those roots.